plus 9y had to be greater than or equal to 567. And 2x plus y had to be less than or equal to 28. And we knew that the x and the y values had to be greater than or equal to 0. So I need what? Where do I go now?
Intercepts.
Intercepts. If x is equal to 0, and if y is equal to 0. So if x is equal to 0, y is doing all the work, which means that we come up with 63 there. If y is equal to 0, then x is doing all the work. And we come up with 7. And because we don't want to get ahead of ourselves, we're going to finish out the intercepts part of the problem first. Bottom equation, if x is equal to 0, then y needs to be 28. If y is equal to 0, then x needs to be 14. Now I have enough information to make an intelligent decision about my graph. But the graph you're given is a 20 by 20 grid. If I got a 20 by 20 grid, I need 63 units vertically. I cannot let each block represent 1 unit, which is going to challenge my plotting of points, which is going to make it very difficult for you to read off the graph, which is exactly what we want it to be. Okay, so 10, 20, 30, 40, 50, 60, 70. Not perfect, but I really don't want to go to thirds because it's too hard to graph in thirds, for me anyway, but I might have been able to. I could have done, now this is easier because I can see 5, 10, 15, 20, 25, 30, 35, 40. I'm going to have to do a little bit of guessing. So there's 2. Now horizontally, I only need 14 units, so I can stay to a nicer scale horizontally and not have to worry about it. No, your vertical scale does not have to match your horizontal scale, but whatever your vertical scale is must be uniform for the whole scale, and whatever's in your horizontal scale must be uniform for that scale as well. So 0 and 63, which I'm going to have to guess at, roughly in here somewhere. Agree? Connects to 7 and 0. A lot easier to graph, wasn't it? So that has to be a line. And I want that line to be blue in color. So there's my first line. 0 and 28. In there somewhere. 14 and 0. Out here somewhere. Now I need a line. I want it to be red. Notice what, didn't want that. Notice what happened. Not going to be able to guess at that. Pretty much forcing you to have to use the reduced row echelon. That's what I mean. That's why we don't want you trying to read off the graph. Because if I didn't do a good job of hitting these points, that value is going to move. And I don't want to be guessing at that. I don't want to be close. I have to get the problem right. Feasible region. Oh yeah, I know, I haven't done that yet. We'll do that, okay. Thank you for reminding me. I need to have the other constraints in the problem technically, but is that really a problem? Because hasn't the graph pretty much told us we're limited to the first quadrant? So on your test paper and support work, I don't think that would be a problem, but if this was a problem on the computer that expected you to graph, you definitely would need those. Okay, quadrant 1. Quadrant 2, quadrant or region 3, and region 4. Where do you want to start?
Quadrant 3.
3? And what point do you want to use in region 3?
5 and 18.
5 and 18? 5 and 18 is not the best choice of points because too close to the line. Now, if you're trying to guess what the intersection is, that might be a good guess, but I don't know. I don't want to do that. So if I'm going to test region number 3 first, I'm going to pick something a little bit nicer. 2 and 2. Okay, so region 3. I'm testing the point 2 and 2.
It's 2 and 10. Huh?
That's 2 and 10, correct. Thank you. 81 times 2 plus 9 times 10 greater than or equal to 567. I'm thinking the 162 plus 90 is not going to be greater than 567, so would you say that region 3 is a no-go? But let's hang on for a second. That means that since we tested it in this equation, which was the blue line, that if it's not good to be on this side of the blue line here, doesn't it also mean that it can't be region 2? So sometimes you get lucky, you can get a 2 for the price of 1. Buy one, get one free. So not only did region 2 fail, because if this is a no, then this also has to be a no without even having to check a second point. 1 point, got rid of 2 regions. Guess what? I only have to check 1 more point. Because if it's not region 1, then it has to be region 4. Or if it's not region 4, it has to be region 1. So, pick your poison. 1. Okay, pick a point. 8 and 20. Okay, so now we're checking region 1. And we're using the point 8 and 20. So now we have 81 times 8 plus 9 times 20. And thank God I have a calculator that will do that work for me. 81 times 8. 9 times 20. And that should give me something that's greater than or equal to 567. So we got a yes to this. But it also has to work in the bottom ones again. So 2 times 8 plus 20 is less than or equal to 28. That's a no. So since this is a no, have we now figured out that it has to be region number 4? So this must be our feasible region. A failure on one test point is not necessarily a bad thing. Not getting a yes answer is not necessarily a bad thing because it can kill 2 regions off of the problem, killing 2 birds with 1 stone. So we know there's our feasible region, and if we know that that's the feasible region, we should be able to come back and deal with corner points, shouldn't we? Okay, so rather than redraw that whole graph, I'm going to again take this and I'm going to clone this page. Copy it. I'll have an extra page now. Okay, so down here, we've got our regions taken care of, and we found out which region was the correct region, so we don't need any of this stuff anymore. Now all we need is the objective. What was our objective function? 1200x plus 110y is equal to cost, and we want to come up with a minimum cost here. What are our corner points? Seven and 0, 14 and 0, oh, haven't found that one yet. If we hadn't found that, it should have been part of the graph section of the problem because it's all part of identifying the corner points. So we need to come back and run a reduced row echelon off of this. And this is not going to be one we can guess from the graph, can we? Okay, so we have an 81 we have a 9, 567, 2, 1, and 28. And when we run that through the reduced row echelon form, it turns out that it's going to be a value of 5 and 18. But for my graph, it wouldn't have looked like 5 and 18, because it looked like I already went past the 5 line. Just to verify, because people are saying, how do you know that? This is only the second time today that I've worked this problem. So we have 81, 9, and 567, 2, 1, and 28. And we need reduced row echelon. And we need matrix A. And there it is, 5 and 18. So our last point down here that we have to consider then is also 5 and 18. So 1,200 times 7. And there is no Y value to worry about in the problem. So that's 8,400. If I rent 7 buses, I can get them all there. It's going to cost me $8,400. If I rent 14 buses, I'm not going to have any vans. That's going to be ridiculous. Twice as much. I don't even want to think about that. That's 168. 16800. 14 is twice 7, right? So that's just 2 times as big. But if you don't believe me, 81 should be 1,200 times 14, 168. 16800. $16,000. Better be some damn nice buses if I do that. 5 and 18. 1,200 by 5. And 110 by 18. So now we have all the facts in front of us. The best way to get my people there for the cheapest cost the minimum cost of is attained by using buses and vans. And that may be the way the question's phrased. And you just have to play fill in the blanks. So minimum cost is $7,980. And I get it by using 5 buses and by using 18 vans. And if I go back